look at the gas management here. So you can see the suction gas comes here. Then suction gas, like high density gas may fall here and pull the motor. The low density gas directly goes up, get into the pump. This is a pump portion. Get into the pump, get compressed and go away from discharge, right? In the discharge you can find here there is a check valve also. Based on the application, there are different check valves used. I think we have a next slide in that. We have two different type of check valves, one with a spring, one with a disc type. Disc type is used for AC. Because AC you don't use pump down cycle, right? So that's why we use this type. When it comes to refrigeration, we use pump down cycle, so we use a spring type check valve. Yeah. So gas comes here, cools this motor, cools this thing, goes up, get compressed, and get discharged from here. Yeah. So this, I really look at the shell from here till here, completely in the low pressure side. Yeah. This is all low pressure. This is all suction pressure, low pressure or suction pressure. From here to here, frame to bottom. Only discharge pressure is only here, this portion, the discharge plenum. Only this portion you have discharged. Remaining all you have this thing only. Yeah. These are two type of check valves. One is a spring type. The spring type check valve, as I said, used for refrigeration application because you need to have a proper sealing. And we have a this type check valve which is used for AC compressors. So why we need a check valve? The thing is, so whenever compressor running, you got the temperature and you are switching off. So there is a difference in pressure, right? You have a discharge pressure and suction pressure. What the discharge pressure does is, in a normal reed compressor, you have a valve plate and the reed. The reed will be closed, so there is no bypass. When it comes to scroll compressor, there is no reed. So the discharge pressure tries to come back to the suction through the scroll. Suction rate through the scroll. When it is trying to come back, it will be rotating the scroll in the opposite direction. Then you will be having a lot of noise. Like some of the places I would have seen, like some noise will be, while stopping it will be making noise. So if you don't have a check valve, this noise will be like extend for 40 seconds or 50 seconds. Because until it gets equalized, keep rotating in the opposite direction. So you don't have power supply, but the pressure is pushing this to run in the opposite direction. Unnecessary sound and all that. To avoid that, actually we have the check valve. So this check valve makes sure that whatever within the scroll, the top plenum, that get expanded, not otherwise. Like the remaining gas won't come back. So this will be taken care of. That's why we need this. The other thing here is like scroll compressor. Generally, all the scroll compressors start unloaded. Unloaded start, we say, right? In the receipt compressor, you have a discharge pressure suction. Even when you stop, there is a pressure difference, right? Discharge and suction pressure when you are starting. It has to start against the pressure, against high pressure it has to start. When it comes to scroll, internally within the scroll, the pressure was getting equalized. Within the scroll, the pressures are getting equalized. This pressure will be all same. This pressure, when you stop, this pressure will be same. So it is easy to start for scroll compressor. So that's why even if it is a single phase scroll compressor, you may not need a starting capacitor, you may not need a starting relay or whatever. You don't need all that, right? Starting capacitor, run capacitor definitely you need for this, with a single phase, but you may not need a starting capacitor and a potential relay. You may not need that. Because it is like start unloaded, always start unloaded when it comes to single phase. When it comes to three phase, you don't have any issue. Three phase has a very high torque, because it is three phase, you have a 360 degree this thing there, like because of which it can start easily. Yeah. This is a check valve. And quickly I'll just look at the oil management here. The oil gets sucked from here. From the bottom, the oil gets sucked here. There is a crankshaft here, or we call it a crankshaft or eccentric shaft. So there is a shaft here. From the bottom of the shaft, the oil gets sucked here. It will be going through this to different locations where the holes are drilled. It will be lubricated in this particular portion and the main bearing, and go to the orbiting bearing. All this will be lubricated through this. So for that, what we are doing is, in the shaft, end of the shaft, you have a flinger. There is a flinger prime pump you have here. So when we have a flinger, when it is running at 2900 RPM, it will be making a centrifugal pump. It will be acting like a centrifugal pump. So it is running at that RPM. So the oil gets sucked from here because of that, and go through all these portions and lubricate this. Yeah. So we have to ensure that, as I said, oil level need to be maintained, not very high, not very low. Generally, oil level will be here. Yeah. So when it goes beyond that, so these are okay. These are rotor, right? You can see a rotor here. If it goes beyond that, the rotor dragging can take place. If the oil is filled up to this, the rotor had to run inside the oil. Like more amount of rotor is immersed with the oil. It has to run against that. So it may take high current and all that. So oil level need to be not low, not very high. Optimum level need to be maintained. Yeah. Little bit higher is okay, but not very high amount of oil. If you have a side glass, ensure that the oil level is maintained in the side glass. Off side glass. You don't worry about the model. Just off side glass, if it is maintained, it is okay. Because it depends on the model. You can have 3/4 or 1/4 or off. But generally, you can take off side glass. If you are seeing the oil, there's no issue. You can just make it. Yeah. So these are it is. Like you can see the finger here, the offset crankshaft. What we use. It is sitting on this lower bearing. It is sitting on this lower bearing surface. But lower bearing anyway, it is immersed in the oil. It will be lubricating. Then the oil gets here, go up, go to wherever lubrication required. It will be going through these parts and goes up, orbiting the bearing, and it comes out again. It just comes back to the suction in the sump. Yeah, comes back to the sump. Yeah, these are the different bearings it lubricate. Okay, so you have a lower bearing which is immersed in the oil, then you have a main bearing, you have a dry bearing or unloaded bearing, and it will be lubricating some of the straddle as well. The straddle also it will be lubricating this portion. So one more thing we have is we call it a DU bearing. So you know whenever we have whenever we have not sufficient oil in the lubricating surfaces, the bearing temperature increases. Then oil cannot stick to that. Then what happens? Like it fails, the bearing fails, and wear because of the wear, right? So we use something called DU bearing. So this is developed by DuPont along with us. So this is a Teflon coated bearing. Teflon impregnated surface over porous bronze substance, substrate, allows for extended operation. So what it does is, if the bearing gets heated up, it will become soft, and it can lubricate for shorter period of time. Little bit extension, even until the oil come back. Not a long period, like if the oil is coming back after 10 seconds, 15 seconds, this can take it. Until then, this can take it. It will become soft and it can take care of the lubrication. Yeah. So these are patented bearing with this. Again, that is on the scroll. Quickly, I'll just show you how our CR compressor looks like. These are our CR and CB compressor. Again, it has a different thing. Like scroll compressor, you see the pump on the top, motor on the bottom. But this particular compressor, you see the pump is on the bottom and the motor is on the top. So you have a suction gas which is generally comes through the motor based on the design. It can just come through the motor, cools the motor, then comes to the pump. Maybe some amount of gas, if it is high density, low density gas, can bypass, go through this tube and come back here and all that. Okay. So the oil will be at the bottom. Again, the oil gets sucked through this and give the bearing the required lubrication. Yeah. So this receive compressor generally fitted on springs. You can see one spring here. There are two more springs at the bottom. There are three springs holding this. So that's why receive compressor generally not used for transport application, because the springs can break inside. There is a discharge loop inside, discharge tube loop that can also break. But when it comes to scroll, there is no springs, nothing. It is all fitted there. What you have is outside you have rubber grommets. That's it, right? So because of which, scroll compressor are more suitable for transport application compared to receive. Yeah. So you have all these bearing containers. You can even transport refrigeration, trucks and all that. A lot of places it is being used, even for bus AC application. A lot of scroll compressor being used for bus AC application. Yeah. Okay.